Okay, so what is the next problem we are going to discuss? Already yes, previous problem. Next problem, another problem we are going to discuss. This one. So the problem given is the locked rotor current in a three-phase. Unmute here also. The locked rotor current in a three-phase star connected 15 kilowatt, 4-pole 230 volt 50 hertz induction motor at rated condition. So here we are going to discuss. So here we take this document again. Correct. So you have to write the given data step. So what is that given data? So here we are, it is a three-phase supply is given here. Then magnetizing current. So we are going to neglect the losses. What are the losses we are going to neglect? Magnetizing current loss, neglecting the losses, and magnetizing current we are going to neglect. So what will be the equation we have to see? So here, what are all the given data? We have to see it out. So it is a three-phase. It is a three-phase phase motor. Okay, three-phase, then star connected. It is star connected. Three-phase star connected, and your values are given and 15. So you have the two currents, rated condition current, induction motor and rated current. So the rated current condition rated current is given as rated current is equal to 50 ampere. Okay, rated current is 50 ampere is given here. Next, we are going to find out the values. So we are taking the voltage. So 230 voltage you have, and another voltage is given as 236. So what is the values you are going to find out? So formula, we have a formula for this. So I2 is equal to, so you have a P2 by Z2. P2 by, just write it as P2 by Z2. So what is Z? Generally we know Z is equal to the R squared plus X squared or X squared will be right. Okay. So here E2 divided by square root of SQRT square root of, so what are the values we have? R2 square, R2 square plus R square plus R2 square plus X2 square. So formula is very, very important. So with the formula only you can find it out. Next, we also know that we are going to do here. They are given that the resistance. What is the conditions you have given? You have to see current law, neglecting all the losses, approximate rotor line current drawing. This it is given. Neglecting the losses, everything. So here R2 is equal to 0. R2 is equal to 0. So here, when you substitute this expression, for I2 is equal to E2 by X2 alone will get it. Instead of Z you are taking the square root of 1. So what will be happening is Z, that is X2. X2 squared root when you take square root will become X2. So that is that expression. So now we are going to find out what is X. Anybody? So X is what? It is omega. Okay, omega into I'm just writing it as W. Omega into L2. X2 is omega into L2. So that is the meaning you are having here. So here we are going to read out. I whatever expression you got this as another expression. It will be directly proportional to frequency. That is E2 by. So it will be directly what is the value? It will be directly proportional to by the smaller is the frequency. Okay, so these are the expressions. So given data is given to E2 by X2. So we are going to write the final expression. 50 is the value given for the rate. Okay, so then we have two voltages, 230 voltage, you have one voltage, 230 voltage, another voltage is 236 voltage, and you have two frequencies, 57 and 50. So all these things we are going to include as a ratio. So 50 divided by 2 dash, we are going to find out because we know I2, we are going to find I2 dash. I2 dash. 2 dash. Find out. Okay, so 50 divided by 2 dash equal to, so you will be having the two voltages. So 230 divided is the other 236. Another voltage is 236. Another voltage is 236 into we have two frequencies. So substitute frequency. So frequency 50 divided by 57. That's all. So when you solve this expression, it will get the I2 dash. So I2 dash will be equal to, so equal to what? So I2 dash will be equal to substitute this value. Now the question if you see we have 4. Okay, so so 45.0 is the value we will be getting after solving this. Try it out to solve. So option B is the answer. Okay. So here when it is a three phase are connected, and another main thing you have to assume here is the and the resistance R2 will be equal to 0. Here process R2 0, R2 frequencies, 2 voltages, and additionally some data will be given. So get used to that. Okay. That's very important. Okay. Next one is the 4-point starter is used to start and control the speed of. So starters have to recall any guesses? 4-point starters, 3 points starters. So what is the 4-point starter is used to start and control the speed of. So why for what purpose we have 4 answers control, then this is more and what is the option here? For starter to start and control here. So what is the option? So option anybody, it is the option. The DC share motor with to distance control. So we use for armature resistance control. Next, three phase and three phase is connected to your infinite bus. So we're going and here three phase starting impulse synchronous motor. We are going to connect when bus is operated at normal section. Normal excitation is no. The motor is first reduced to zero and then increase the first direction. The question is reduced to zero and it's increased in the reverse direction gradually. Then what about they're asking about the armature current? Okay. So when it is increased in the reverse direction, what will happen? Reverse direction means what will happen? So first the mode it's reduced to zero and then it is increased in the reverse direction. So what will happen is the back EMF will go to zero. So when the field is reduced, what will happen? The back EMF will go to zero. So current input will be increased. So the current input will be increased here. But when field increases, the back EMF will cause the current to reduce. So what will happen when the field increase I take and the back EMF will make the current to reduce. Okay, so first because it is in the reverse direction, what we have to understand here is first back EMF. Back EMF will go to zero because first we are reducing it to zero now. So it will back EMF and first will go to zero. Current input will be increased then. But when the field increases, what will happen? So we are gradually increasing and decreasing the field. What will happen? The back EMF will cause the current to reduce. So here when you take, what will be the option? So option first increases. So we have four options. Increases continuously. First increase and then decrease. First decrease and then increase and remains constant. Okay, so second, so what I told you, first it will go on increasing and then starts decreasing. So the second one is the correct one. Okay, first increase and then it will go on decreasing. Okay, next one. A single phase air core transformer fed from the rated sinusoidal supply is operating at no load. Steady state magnetizing current on by the transformer from the supply will have the waveform. So we have four waveforms is given. So we should be thorough with all the waveforms that MD can easily understand. Okay. So here what they are asking, single phase air core transformer. It is an air core transformer fed from the rated sinusoidal supply. It's operating at no load. It is operating at no load condition. Steady state magnetizing current drawn by the transformer from the supply will be the waveform. So you should know this waveform, which type waveform you have. Is any idea? So in this, what is the main logic you have to know is airport transformer has linear BH curves. BH is the intensity and the H is the flux intensity. So we have always a flux density and flux intensity. We will be drawing a graph between the flux and flux intensity. Okay. So what will happen? And which implies that magnetizing current characteristics will be perfectly. So it is output the question you understand is so it is operating, it is the supply is operating at more, it is state magnetizing current. So it is magnetizing current, then what is the sinusoidal wave? Sinusoidal will be a perfect one. The output sinusoidal output will be a perfect one. So Your C option is correct in this. Okay. So whenever it is linear and it is steady state condition, what will happen is your sinusoidal output now when you see that output will be uh, proper. Okay. Next, the 220 volt. I'll take this problem. Next problem number 10. So you volt DC. See students need that you have please ask me. You have any doubts you can ask me. And you can ask me. Or else I'll go for the other one. Okay. Okay. So here we are having a 220 volt DC shunt motor that is operating at 1440 RPM. Okay, 1440 RPM. The armature resistance is the, they have given the armature resistance. The armature resistance is given so as 1.0 watt and the armature current is 10 ampere. So it is the excitation of the machine is reduced by 10%. So that thing you have to understand. Reduced by 10%, the extra resistance to be put in the armature circuit to maintain the same speed and the torque. So what they are asking, what is the thing is they are asking what is that extra resistance we have to use to make to maintain the same speed and the torque. For maintaining the same speed and the torque, what is the extra resistance we have to use? Now initially we have the formula. The previous itself we know this formula. The same formula you are going to write it here also. So what is that formula? We have the voltage given given is equal capital V is equal to 220 volt. Capital V is equal to 220 volt. So here the current make it 20 volt. Then add the armature resistance. So armature resistance in the mass resistance. Armature resistance is given as 10 ampere. Resistance is given as 10 ampere. Okay, then armature current I armature resistance is 10 ampere. Then armature current then armature resistance is equal to 1 so armature resistance is given armature current IA. Armature current is given as 10 ampere. Armature current is given as 10 ampere. So to substitute this order formula, so we know the formula the backing of formula. The same formula will be used for us. Is equal to so we is the expression. So here substitute is equivalent. Okay, so From that first we'll find, you know, what is the experience? Okay. So yeah. So we have to find the value of EB. So EB is equal to, again I think, G. So G is 20. Is 1. So that will be getting, so 229 is equal to 10. Sorry. So this to find out the formula here, 8 by 1 the same concept, same formula. See, repeated, they are asking this formula. So you have to be right. Again, I'm just taking this. So this is the expression I'm taking. So UV by H. So both EMF, okay. Both are back EMF. So we are not going to find out the batch notes. We are having to pay. So I told if you put the ratio as 2, we will get this one. You can rectify it. Okay, so here N2 by N1 I'm writing. So here again this pi value will become 2 by pi 1, 2 by pi 1. Okay, now this one we are going to find it out. Okay, so here we are going to put out the value of the EB value. So here N1 and N2 turns, number of turns are N1 and N2. Question, see the question. The armature is 1.0 watt and armature current excitation is reduced. All these things we know, same speed and the same torque. So your number of turns, capital, I can put a small instead of thing. I can put it as capital N, N2 by N1. So N2 by N1 is the 5 by 2 by 5. So that is equal to, so VB we have found it out now. So VB values, so it is 5 value. So 5 by 51, everything is included here. N2 by N1 will get cancelled because they are equal. N2 by N2 is equal to N1. I'm sorry. N2 is equal to N1, that will get cancelled. Okay, so 5 by 51. So 5 by 51, what is that expression you are going to write it as? This one is EB1, EB2. Okay. So now I'm going to find out EB1, EB1. See. Sorry. Okay. So here we have N1. So this number of turns, the primary number of turns is secondary. So both are equal. So that way we can neglect it, okay? Okay. So we are going to substitute the values. So it's EB. So this one will get letter. So we'll be having EB1 is equal to EB1 is equal to 0.9. So 5 to 1. 5 to by 1 is value of 5 to by 1. So 5 to by 5 already have. So so 5 2 is equal to actually the relation to equal to 5 and 9 into 5. 0.9 into 5. So that is your 5 2. So 5 2 by 5 1 instead of 5 2 by 5 1, I can write it as 0.9. So EB1 will be to 0.9 into EB2. So this total N2 by N1 will get cancelled because number of turns in the secondary and primary are equal. So 0.9 into EB2. Point 9 into EB2. Okay, so here will be using here. So we want to do EB2. So on expression, we have expression here. So EB is equal to B suffix B is equal to B minus IA, B minus IA into RA plus R. Plus R. So this is the. So from that we are going to calculate the additional resistance. So we know EB, we know V, we know everything we know except R. So from that we can calculate the values. So 189 CB value. So here that value is calculated, multiply 0.9. Okay, so 0.9 when you multiply with EB2, you'll be getting this answer. So here the EB value is 189. 189 0.9 into 210. So 210 is the voltage, EB voltage. So 210 into 0.9 will be so 0.9 EB2 now. So that is equal to that will be equal to 189. Okay. So 189 is equal to 189 is equal to V voltage is 220 minus IA. IA value is IA value will be calculating from 5 to 5 1. So 5A1 IA2. So values what here is 2 I IA2 IA2 So your IA2 value will be equal to 5 by 5 1 into that is 5 1 by 5 2 into IA1. Okay. Not 1 2 means you'll be getting IA2 5 1 by so you'll be getting IA2 as IA1 into 5 1 by 5. So from that we can calculate the value of IA. Okay, so IA2 will be equal to no expression is equal to will be having this expression. So here 10 1 by divided by 0.9. So this will be so 10 what is getting is 11 point. Okay, that you should all this that is very okay. Um, I'm just substituting all this is 11 converted into the base 1 or 1 1 plus. And from this we can calculate the value of R. So this the resistance we need to use to maintaining this speed. This is the one problem. Problems are very more formula to understand. You have any can ask me. Yes. Okay. The remaining topic we'll see in the next class. Okay, Padi, you have any doubt? Ask me or otherwise, thank you.